All right, in this video, I'm going to go through the study guide 1. So the first question is a little weird because there's a n exponent on the tangent function. I'm not sure I don't think you'll see that on the test, but it doesn't make a big deal. Just treat it as any number. And so we're going to make a u substitution. In this case, we're going to use u equals tangent x. And the reason we want to choose u equals tangent x is because the derivative of tangent is also in the integrand. Tangent derivative is secant squared. So du equals secant squared x, which means that we can replace secant squared x dx with du. So this entire quantity here can be replaced with du. And so that turns our integral into u to the n du, just because this can all be replaced with du. And tangent to the power of n is just u to the n. And so when we integrate this, we just use the power rule. So we increase the exponent by 1, take a reciprocal, and then do a plus c because it's an indefinite integral. And so finally, we want to replace u with tangent. So this becomes tangent x to the n plus 1 power. Here we also want to use a u substitution. In this case, u will equal 2x plus 1. And taking the derivative, that means du dx equals 2. So that means we can replace dx with 1/2 du. And so this integral becomes 1 over the square root of u, and then dx we replace with 1/2 du. This can also be written as any constant can be brought outside the integral, 1/2 u to the negative 1/2 power du. Because a reciprocal of a square root is a power of negative 1/2. All right, and so to integrate this, we're going to increase the power by 1 and then take the reciprocal. So negative half plus 1 is positive 1/2, and the reciprocal of positive 1/2 is 2. So this is going to become 2u to the 1/2 plus c, which leaves us with square root 2x plus 1 plus c. All right, here we also want to use a u substitution. So we're going to do u equals 3 pi x, which means that du dx equals 3 pi, because that's a constant in front of the x, which means that we can replace dx with 1 over 3 pi du. So the integral becomes integral of pi cosine 3 pi x. So pi cosine u, and dx we replace with 1 over 3 pi du. Now the pi's cancel out. We're left with integral of 1/3 cosine u du. And the integral of cosine is just sine. And so we have 1/3 sine u, or sine 3 pi x, plus c. Okay, if you were stuck, you could always go back and just differentiate all the different choices, because you know that the derivative of the integral must equal the thing inside the integral. Here is a u substitution. We want to choose u equals tangent x, because the derivative of tangent is secant squared. So this is going to give us du equals secant squared x dx. And so this quantity here, we can just replace with du. And so the resulting integral is just integral of 8 over square root u du, which I'll rewrite as 8u to the negative 1/2 du, which is just going to be 8 times Negative 1/2 plus 1 is positive 1/2. 1 over 1/2 is 2. So 8 times 2u to the 1/2 plus c, or 16 square root tan x plus c. Find the indefinite integral and check by differentiation. This is another u substitution. U equals t cubed plus 1, which means that du dt equals 3t squared. And so that means that this quantity here, 3t squared dt, is just equal to du. So the integral will become 1 over square root of u, and then 3t squared dt is replaced with du. Okay, how do we check this with differentiation? We're just going to take the derivative. And this is something we can do with chain rule, right? So we're first going to take a derivative of the square root. That's going to leave us with coefficient of 1/2. And then the power will reduce by 1. And then we need to take a derivative of the inside. So we're going to have 3t squared multiplied at the end. And then the plus c leaves a derivative of 0 because it's a constant. So this simplifies as 3t squared over square root t cubed plus 1. Okay. All right. Here we have a definite integral now. So first we want to find the indefinite integral and then plug in the upper and lower bounds and subtract them. So the indefinite integral here is going to be 4 over 4x to the fourth minus 6 over 2x squared. Okay. And then we're going to draw the vertical line to indicate that we have a upper and lower limit that we want to do subtraction with. I'm also going to simplify the inside, which gives us x to the fourth minus 3x squared. And so if I plug in 2, I'm going to have 16 minus 3 times 4, which is 12. And then if I plug in 1, I'm going to have 1 to the fourth minus 3 times 1. So this becomes 4 minus negative 2, or 6. This is also a u substitution. In this case, we want to choose u equals sine x. Why do we choose u equals sine x? That's because the derivative of sine is right here, cosine x dx. Because if we do du, we're just going to get cosine x dx. So that means this integral can be replaced with u to the fifth, and then cosine x dx is just du. Integral of this is 1/6 u to the sixth plus c, which is also 1/6 sine to the sixth x plus c. Next, find the indefinite integral. It's another u substitution. Just going to do a change of variables essentially. So u equals 1 plus 2t, which means that du dt equals 2, or dt equals 1/2 du. All right. So the integral is going to become u to the fourth, and dt will replace with 1/2 du. If you integrate this, you should get 1/10 u to the fifth plus c. And this is just 1/10, and what is u? 1 plus 2t. 1 plus 2t to the fifth power plus c. Okay, value the definite integral f of x from 4 to 11. using geometric formulas. Okay, so we're looking at this area here, right? So 4 to 11. I'll label the different areas, 1, 2, and 3. So the area of region 1 is a triangle, so it's 1/2 base times height. Area 2 is also a triangle, so let's do 1/2 base times height. The base is 4 here, and the height is still 2. We should have a negative area because this is under the x-axis, right? So we'll have -4. Then region 3 is 1/2 base times height, which is 1/2. And so putting these together, we should be getting -3/2, or -1.5. This is a U substitution again. So here u equals z to the 8 plus 2. So that means du dz is equal to 8z to the power of 7. Okay? So that means that in this integral, we have z to the 7th times dz, right? So that means we're going to want to isolate z7 dz. And if we do that, we should get 1/8 du equals z to the 7th dz, which means that we can replace this quantity here with 1/8 du. So the integral is going to become 1/8, and z to the 8 plus z to the 8 power plus 2 is u to the 4th power, and then z to the 7th dz will replace with 1/8 du. And so if we integrate this, this becomes 1 over 40 u to the 5th plus c, and 1 over 40 u to the 5th we can replace with z to the 8 plus 2 to the 5th power, because u is originally z to the 8 plus 2.
Brooklyn Big Boy, and Faith Staci, I think.
So Faith is, she's great. We've known the Sodleys for a little.
Okay.
Mark actually took a wedding for.
Oh, really? Okay.
So my wife has worked with him.
Yeah.
Question 11. This is another question where we do u substitution. And
Faith is on.
here u equals t cubed plus 4.
Here. But she is Faith.
And if we take the derivative, du dt
Oh, she did, okay.
is equal to 3t squared.
Doing great.
And that means we can replace dt with 1 over 3t squared du. So if we plug this into our original integral, I have t squared
Yes.
times the square root of u, and dt is 1 over 3t squared du, which means that the t squareds cancel out. We're left with the integral of 1/3 times the square root of u, or we can replace that with u to the 1/2 du. So this is 1/3. Then if we integrate u to the 1/2, we raise the power by 1, so 1/2 becomes 3 over 2. So that gives us a coefficient in front of 2/3. 2/3 u to the 3/2 plus c, which we can simplify as 2/9. And u is t cubed plus 4, 3/2 plus c. So that corresponds to answer choice E. Question 12. This requires us to use the fundamental theorem of calculus, which you should remember. So anytime we have an x as the upper limit of integration, when we take a derivative of the integral, we're just going to get the original inside of the integral. And so, generally speaking, anytime we have the derivative of an integral and we're differentiating with respect to the upper limit of integration, then this derivative is always just going to be f of x. It's going to correspond to essentially plugging in this x into whatever we have inside the integral. And so in this case, f prime of x is really just going to be square root of x plus 3. And that's it. Next question, find the average value of the function. So remember, if we want to find the average value of a function, we want to find the area under its curve and then divide by the width. So if we're looking at an interval between xa and xb, then the width is always b minus a. And so we want to take this area, which is given by the definite integral, and divide by the width, b minus a. And so the general formula is 1 over b minus a, definite integral a to b of f of x dx. And so in this case, a is -2 and b is 2. And so we're looking at 1 over 2 minus -2, integrating from -2 to 2 of the function 30 minus 6x squared dx, which will just give us 1 over 4. And then what is this integral here? We're going to want to find the indefinite integral first, and then plug in the limits of integration. So the indefinite integral is 30x minus 2x cubed, and we'll be plugging in 2 and -2. It's going to be 1 over 4. Okay, first we're going to plug in 2. That should give us 60 minus 16. Then subtract, plugging in -2, which will be -60, and then minus 2 times -2 cubed, which will be plus 16. So in end, we get should be 22. 1/4 times 88, which is 22. Next, we can do the calculator portion, so you can use a calculator on this section. First question, we want to find the position function given the acceleration and initial conditions for the velocity and the position. So just need to remember that acceleration is the second derivative of position. So acceleration is the second derivative, which means that to go from acceleration to position, we have to integrate twice. And the constant plus c after the integral is just going to be given by whatever the initial condition we're given is. So if we're starting with a of t equals 8, then that means the velocity, which is the integral of acceleration, right? Because velocity is the first derivative and acceleration is the second derivative, so velocity should be the integral of acceleration. That just means that velocity will be integral of 8 dt, which is 8t plus c, where c is some constant. And to identify what c is, we just need to plug in whatever initial condition we're given. So we know that v of 2 should equal 9, which means that 8 times 2 plus c equals 9, which tells us that c is -7. So that means that velocity is 8t minus 7. And then to get from velocity to position, we just integrate one more time, which gives us 4t squared minus 7t plus c. And then position at time equals 1 should be 0. So p of 1 should be 4 minus 7 plus c equals 0, which means that c equals +3. And so the final position function is 4t squared minus 7t plus 3. For the next question, to do this integral, you're going to need to use a calculator. So let me just do that online. Your answer should be about 0.189. So make sure you know how to use the TI-84 to do this. Okay, this one is very similar to what we did previously. Anytime we take a derivative of an integral with x in the upper limit, the answer is just going to be the integrand itself. And so that means the derivative of f of x here will just be the square root of x cubed plus 1. And then if we plug in 2 for x, it's just the square root of 9, which is 3. For the next question here, for part A, we want to use the fact that the integral of 0 to 7 is just equal to the integral of 0 to 5 plus 5 to 7, right? That should be fairly clear just based on how we think about the integral as an area. It's like we're connecting two different intervals together, right? We have an interval from 0 to 5, then interval from 5 to 7, and we're just adding them together to give us the integral from 0 to 7. And so that's going to tell us that the integral of 0 to 5 is just equal to 13 minus 3, which is 10. C is just 0 because this is an integral with 0 width, right? The upper and lower limits are the same. B will be -13 because the integral of 0 to 7 is just the negative integral of 7 to 0 because we're calculating the area either left to right or right to left. That will give us a negative. And finally, for this one, we're integrating 3 times the function, right? And so that should give us an area that's 3 times the original integral. So the answer is 3 times 3, or 9. All right, here we have a question asking us to do a midpoint Riemann sum. So I taught you guys this last class. A midpoint Riemann sum requires us to have to calculate the height of the what's it called? The height of each rectangle based on the midpoint of its interval. So we're gonna have 3 subintervals here. We have a subinterval 0 to 2, and then another interval 0 to 4, and then a last interval 0 to 6. And the question is, how are we going to determine the height of the interval? The height of the interval is going to be determined by the value of the function at the midpoint of the interval, so at 1, 3, and 5. And so that means this height here is going to be 7, because that's the value of the function at 1. This height here is 12. And this height here is 22. Okay, and so that means that the total area approximated using a midpoint Riemann sum is 2 times 7 plus 2 times 12 plus 2 times 22, which is 100, is it? 82. 30, 41, yeah, 82. So E. All right, here we're going to do left, right, and trapezoidal sums. So let's do the right Riemann sum first. All right, so remember our subintervals are 3 to 6, 6 to 11, and 11 to 15. So what's the height of our first rectangle? The height of the first rectangle, we're doing a right Riemann sum, right? So that means we're going to calculate the height based on the rightmost part of the interval. And so the height of the first rectangle will be 20, because that's the value of the function at x equals 6. Height of the second rectangle is going to be 35. The height of the third rectangle is 30. So the total area is going to be 3 times 20 plus 5 times 35 plus 4 times 30, which is 60 plus 175, 235 plus 120 is 355. Right. Yeah, I think that's correct. Next one is a left Riemann sum. So here we're calculating the areas of the rectangles based on the left part. So the height of the first rectangle is 10. Height of the second rectangle is 20. The height of the third rectangle is 35. So that's 3 times 10 plus 5 times 20 plus 4 times 35, which is 30 plus 100. 130 plus 140 is 270. Okay, and the trapezoidal approximation is just the average of the left and right Riemann sums. And so the average is 625 divided by 2, which is 312.5. That's 355 plus 270 divided by 2. So, yeah, 625 divided by 2, 312.5. Last question is the average value. And so we're going to do, right, remember 1 over b minus a, integral of a to b, f of x dx. So in this case, b minus a is 5 minus 3, so it's 1/2. We're integrating from 3 to 5, and f of x here is natural log cubed. Obviously, you can only do this with a calculator. So this is going to be 1/2 times integral of cube of natural log from 3 to 5. So this should be about 2.692 using your calculator. And I hope that's correct.